Hello and welcome to the build and release call for the Falco project. This is our first call. I am your host, Chris Dova, coming at you live from downtown Milan, Italy. And today we're going to be going through the Falco build and release and talking more about it. We have a HackMD, which will add links to this to the YouTube video as soon as we post it. And of course, we'll follow up with an email to the mailing list as per usual. And with that, I'm going to hand it over to Lorenzo to start going through the agenda.
Okay, hi everyone. So first item is done. You're welcome. Make a decision if we want to keep doing pre-built probes for everyone, or we prefer to build a more stable local build experience. This has been a long-standing issue. Right now, whenever a Falco release is rolled out, we build the kernel driver probes and not anymore the BPF probes, and we push them on an S3, which basically lets you download them when you need them. The problem with this approach is that on one side, it's very handy because if you have a very common distribution, it works very well. Like if you have Ubuntu with kernel 4.14 with the classic configuration. I hear a Chris, can you mute yourself? Okay, thank you. Oh, wait a second. I'm getting crazy with that.
Hold on 1 second.
Thanks. Oh, finally. So with the classic configuration that if you have a kernel with a classic configuration, it works very well because it just downloads it. But on the other end, like a lot of users are just saying, hey, it doesn't download for me. And the script that does that is just a bash script that if it cannot find them on the S3, it will try to build them locally. So both the approaches have their problems. The one where you download them have the problem that we cannot build for all the combination of possible kernels, distributions, and kernel config flags because it's billions. And the other of building locally has the problem that we will need to put, we have to put GCC and tool chains on the container that builds that. However, building locally is still the best option because it's very, very easy to achieve. But so I think that we should do a combination of having a pre-built probe, but not provided by Falco. So we should tell the users if they have a lot of nodes with many different configurations where they are not sure if they can build on the nodes the probe, we should tell them how to build them for their infrastructure and then how to distribute them to all of their Falcos. And for those that don't need that, we should build locally and stop providing this infrastructure part, in my opinion.
But
also because,
just a quick question: is there a set that we want to validate because like we're gonna miss regressions if we don't like run building the infra right? So if we assume people are gonna build locally.
What do you mean? Do you think that having to build all the kernel combination will help us with testing?
Will it? I'm not sure. Just
I don't think it does.
Okay.
Because well, that's another point. If we want to add a test suite that runs nightly, that does kernel testing on a matrix, I totally agree, but it should be focused on testing. Some times ago, me and Leonardo made a script to basically spawn on Travis or CircleCI, whatever, kernel with KVM, with specific config flags, we can share that script to let you start a matrix. I don't think we should actually, because the way it's done now, but it's a SysDig internal thing. It's that's why we need to redesign this, because it's Falco is not in the CNCF. We just go to download the kernel sources on the various distributions, and we start a machine that uses those kernel sources to build the Falco driver. The way it will be, I think, we'll say right to do that is to use a kernel with multiple distribution. What I mean, we start a kernel like with KVM that we build from scratch from the kernel source code or from the distribution source code, and then we start a set of containers on it that have different root of file systems. So that would be another way. But I think for testing we need to. It's another thing. This was just for the kernel probe builder. And if we provide a better kernel probe builder, and while doing this, we should provide a better kernel probe builder, because if we remove the pre-built kernel probes, people will start complaining more because they cannot download them anymore. And so we need to tell them what they're supposed to do to get Falco running on the infrastructure.
So, I mean, it sounds like to me, like looking at this from a high level, that there's sort of two main options here, and there's pros and cons to both. The first one is, as a project, figuring out how we solve building the kernel modules and the eBPF probes that people need, and even understanding what people need, and hosting them somewhere. Or two, just getting a better story around how we would be able to build these locally. And I think, the two biggest problems to each approach that I can see, number one, people blindly downloading kernel modules from the internet. That's just seems to be fairly worrisome just in general, right? And then I think, as far as building locally goes, like it's not a simple task to build these kernel modules, right? You need the Linux headers installed. And if this isn't something that you do every day, it's probably going to be a pretty complicated process for you to go through and actually figure this out. So I think, as a project, we probably should decide, which of these two avenues we want to support as an open source project. And, whichever way we go, or even if we go both ways and just see which one is more successful, I definitely think there's a need for some documentation around how to do a lot of this, and just to make sure that people understand kind of, one, what the problems are, what the constraints are, and two, here are some ways that we support solving this problem. I mean, I think if you look at how we're doing things now, we're losing a lot of data every time somebody tries to download a probe. So right now we generate a URL. If that URL happens to be resolvable and happens to have a probe or a kernel module that's built for it, it works. And if not, then it's a 404 and you're kind of out of luck, right? So here it looks like Lorenzo pulled up the S3 bucket that has all of the kernel modules and probes listed here. And you can go and see all of the different ones that we have available based on different kernel versions and architecture and operating systems. So I think, we could be smarter about how we host this and how we track what people are looking for. Every time somebody gets a 404, that's a missed opportunity for us to document the type of people who are consuming a lot of these. And also just looking at this list in general, and I opened up a PR to Falco with some guidelines about the language that we start using as a project. The fact that we're even calling this file Falco probe, and then if you look at the extension, it's a kernel object, seems to be a bit of a misnomer here. I think, being very clear and diligent about, the differences between kernel modules and eBPF probes is very important, specifically because a kernel module can deadlock your system, right? It can crash your kernel, whereas eBPF has a guarantee that you would never be able to do that, which is kind of the whole point of using eBPF in the first place. So I think, yeah, there's a lot of room here for us to improve this process and start to document and understand how all of this works.
Can I make another kind of proposal around this based on what you said?
Yeah, go for it.
So if we look at this URL, it's Falco version architecture, kernel version, in this case 4.7.3 CoreOS, and this is an hash of the actual configuration file of this kernel. So if you do zcat proc-config, this is like an MD5 sum of that, okay, or a SHA sum.
Yeah, whatever.
So, this is what happens. So if you look at the number of combination, like every line in this file is a config option, it will be either true or false. So it's this number 2 times. So we will need to have, 20,000 combinations for every kernel version, for every Falco versions, depending on, the kernel. So it's a lot of stuff if we want to build everything, but it's not possible. So what I will suggest is that another thing we could do is that the script, the program that goes and try to download, it's not just a curl, but it's something more complex, more sophisticated, that goes there and says, I want the Falco kernel module for kernel 0.18.0, for Falco 0.18.0 for this kernel version with this specific set of config flags, so that we can go and build that for you, and in 10 minutes it will be available. So, you know what I mean? Like the fact that they try to download triggers the build, so that maybe the crash will back off for an half hour, but then it works.
So just to make sure, sorry, Lord is sitting right next to me, so I'm going to kind of look this way while I talk to him. But just to make sure I'm understanding you right, you're kind of proposing having some sort of system or some sort of tooling that we have yet to build in place that, basically behaves like an API that kicks off a build. And users would go and say, here's all the inputs you need to build a specific, whether it's an eBPF probe or a kernel module, here's the inputs you need. You send it to the API. If we happen to have built it in the past, we just have that cached and we just return very quickly. And if not, we kick off a build and, they can come back later. It's eventually consistent and then they can download it later. I really like this idea, just off the cuff, particularly because if we build this in open source, we can then use that as, we can say, if you're interested in building and supporting your own kernel modules, here's the tooling that we use, and you're welcome to implement this internally as well, which as far as PCI compliance and other compliance goes, that's going to be a big concern for a lot of folks, in the financial industry, banks, things like that. If we want to start off a project, I think we have resources to make it happen. I think, the build and release process in general was probably, when we did a call for contributors and maintainers, was probably the number one thing that people were most interested in collaborating on. And I think it's a good opportunity for us as a project to solve this problem of, making Falco consumable and user experience and ultimately driving adoption to Falco. Thoughts? I see a lot of heads shaking yes, so I feel like this seems like a good idea, but...
Yeah, it seems. Yeah, I never did like builds like that with so many permutations, but creating this API layer in the middle, sounds like a good idea.
In the end, I don't want to say it will be just, but it will be just cloning the kernel source for that kernel version and passing this file that I'm showing here to the build, and this file will be coming from the user that tried to download the probe and build the kernel module with the config set. Of course, there could be some issues with distributions having their own kernel source and stuff, but we can figure that out, in my opinion. And it will be very cool to have these, because there's many projects with this issue other than Falco if we make a system that is generic enough. Like VirtualBox has the same problem. All the projects out there that have a kernel module.
Yeah, that's the other question I had. Like, was this problem solved before by anyone, or like?
Yes
you
and
said,
no.
no. Okay.
In a sense, let's take VirtualBox as an example. They are many enough to basically package a VirtualBox RPM and dev package for every kernel version, for every package. Like VirtualBox is in the Ubuntu package manager by default with a name. There's a team that manages the release for every Debian version, for every kernel version. But even if we do that, I don't think we will fix the problem we have, because most of the users that will be using us probably will use the new container distributions that don't have a package manager, these kind of things. So we will still have the problem. So I think that having this kind of mechanism would be a good idea, because you ask for something, it's not there, but it will be there when you check it again. And if we make the thing built in like 10 minutes, it would be very good as an option for everyone, in my opinion.
It also gives us visibility into the types of users we have consuming Falco, right? Like if we're building these on the fly as operating systems evolve and we don't ever see CoreOS show up in the logs, we know that for some reason, folks who are running CoreOS aren't running Falco, or we can start to make assertions like that and just understand who's using it.
And we can also use that to focus on what kind of things to build in Falco itself, based on the operating system and flags that people use. Like if we see that no one's enabled C groups in their distribution, we don't support C groups anymore in Falco, for example. I mean, it's unlikely, but.
So two questions that I have that kind of come to mind here. And this is in the name of user experience. You know, as a cloud native operator, a Kubernetes operator, you know, you would want this process to be fairly seamless and fairly reliable. So I guess the two questions are, one, do we need to have tooling in place? Maybe this is a good example for a use case in Falco CTL. You know, Falco CTL, download probe or something, and it'll pull /proc/config. It will, you know, hit the well-known service endpoint, and then it'll, you know, maybe sleep and check back every 60 seconds or something to see if the probe is there or the module is there. And then the question I have is, what do we want Falco to do behavior-wise if a module or a probe is not loaded on the system, right? So like right now, if it's not loaded, Falco, I mean, it starts and it exits within 2 seconds at the most of execution time, and basically says, I don't have what I need, sorry. And, you know, exit non-zero and have a nice day. So do we want to, you know, continue with that behavior, or do we want, you know, Falco to have a feature flag that will try to download it, or, you know, does it time out? Like, what does that user experience look like as far as interfacing with this new potential system?
I'd vote for second. Yeah, I'd vote for second one. The second option you said. It would more user experience wise. There's a feature flag and all. Yeah.
Feature flag, you know, -- download module or download probe. And, you know, we look if it's on the system. If it's not there, we have a well-known service endpoint. We curl that endpoint. If it's there, great, we can move forward. If not, we sleep, time out after, you know, 5 minutes or something, and try every 10 seconds or something like that.
I think you should continue checking and warning you about that, so that you take action and tell you what to do. Like use Falco CTL to download it, so that you can react to the issue. I'm not sure it should be downloading it, honestly. But I think
Yeah.
it's a big issue.
It depends how you build your clusters too. Like if you just create like an AMI or something, and then with your nodes, it depends.
Yeah. I kind of feel like we should keep the scope of the Falco daemon itself relatively small and just get better about how we report errors and giving users a path forward, right? Like there's nothing more annoying as an operator than, hey, this doesn't work and here's a meaningless error message. Good luck trying to figure it out.
Mm-hmm. Yeah, I agree.
And
So,
I was also going to say, like, there's also nothing more annoying as an operator than software that does way too much magic, assuming that it knows what you want it to do and it tries to solve all these problems you may or may not even care about.
Yeah, agreed.
I agree. And also, imagine being an operator and you know that Falco needs a kernel module and you want to take care of it yourself. Like, let's say that you're running, I'm using CoreOS as an example just because I know some of it. You start CoreOS and the init of the machine, you start Falco CTL to download the kernel probe because the kernel of this machine will not change until the next boot. And so every Falco that will start in this machine will already have the kernel. And you already have it prepared before you even start putting the kubelet and everything. So you already know that Falco will be working on that side.
Yeah.
So you should let the user decide how they want to provision.
Yeah. Like we used Packer at my last place to provision the nodes and some scripts.
Like for those using Packer, they wouldn't even need to download. They download it one time, like the operator.
Yeah, that's it. That's the other benefit.
Yeah.
Okay, so it sounds like the consensus here is kind of keep the scope of Falco small, build ancillary tooling to help out with this process to make it easier for operators, and then just be very diligent about, our guarantees that if Falco doesn't have what it needs, it exits non-zero very quickly and also informs the operator, here's documentation, here's a tool, here's a path forward. And if we want to explore ideas like having a init container that does the timeout and the download and tries to bootstrap Falco, we can start to build that around the core program, which has a very small limited scope.
That's a very good idea because it's a provisioning phase and not by far very good.
Thoughts?
For the init container phase, I'm not sure. It depends. Like I think I saw in the roadmap, Falco at some point will not run as root or something like that. So it depends what kind of power you wanna have in the container phase.
Yeah, I agree with you because at some point Falco will probably not even have the inputs in it too. So adding code to let Falco download and stuff doesn't seem going to that path to me. So if we don't make that kind of changes to Falco, instead we have, you want to use an init container because you don't have Packer, or you want to use an init container because you don't have the init script in your machine, or you want to create an image with the Falco module in it. Whatever you do, just make sure that the Falco module is in Falco before you start Falco. Is in the machine before you start Falco. That should be. And if it doesn't, Falco should say, hey, you don't have the Falco module. The way you get the Falco module is by using Falco CTL.
Meaningful error messages.
In my mind, it's like the Falco version of like the Terraform, like the big red, like with all the asterisks that everyone is used to seeing, just like having a big, like, here's what happened, here's why it happened, it's a common problem, but you're in luck because here are the steps you can take.
Yep.
Cool.
And while we do this, we should make sure that Falco CTL and all the scripts we made, the programs we made, are easier to be used inside tools like Terraform, Packer, all those infrastructure automation tools, because sometimes you design a tool thinking about the command line user, while then people automate stuff and maybe they cannot take the error in a machine readable way or whatever. So that I think should be in our minds while we do this.
Agree. So I think next steps for solving the kernel module and probe dilemma here. I've been taking some notes in the document. It's under the discussion on kernel module eBPF. It's the third item down. Lodi, can you pull up the proposals that we did for the API in Falco really quick? We probably should send a proposal.
The proposal, yeah.
Yeah. Just to get a lot of this in writing and kind of just have the technical detail explained somewhere. I mean, there's a lot of implementation detail we need somebody to think about. You know, does this run in a container? Do we run this in Kubernetes? Do we encrypt the API? Yeah. So yeah, if we could just create a document like this with kind of our thoughts and feelings around the service that we would potentially want to build and what that means for Falco, Falco CTL, all of this, and give the folks in the community an opportunity to thumbs up, thumbs down, ask questions, poke holes.
There's a template somewhere.
Okay.
I don't remember where, but if there's
Any-
not, we can use one of those.
Any volunteers to take a stab at kicking this proposal off?
I can help review it, but I'm not sure I have enough time to build the initial document.
Okay. Okay. I think I can, at the very least, I'll open up an issue that kind of gets us started. And, you know, between myself and other folks on the Falco team here at Sysdig, I'm sure we can get something together fairly soon. And then it sounds like this is rare, especially for an open source project. It sounds like we might have an opportunity to do some greenfield software engineering, which is always exciting. Cool. So yeah, if we want to assign at least getting a lot of this written down and documented in the repo, to me, I'm happy to get that started.
Can you write to the document because I lost track of where we are?
Yep, give me one moment. If you want to move on to the next one, while I kind of, I'll mute and I'll write a lot of this down.
Okay, init containers now.
I can't hear you. I think you're muted.
Oh, I'm sorry. Discussion about init containers for Falco, see issue. Okay, now let me open the issue. Deprecating Docker image, I think this merits a holistic review for Docker files. Can you please audit and document container image as we supporting? Oh, this is another thing. What did I open? Is that? Yes. So Chris, I think you should talk about it because I don't know what you wanted to talk about.
Okay, yeah. So can you go back? I'm going to take my headphones off. Yeah, so if you look at this, issue here, it links to 1015 if you want to click on that. So basically what happened was the other day I was trying to get something merged and the Docker build was failing because we were calling Debian unstable and there was a known bug with, I don't even, it's documented in here somewhere. Yeah, right there at the bottom, another bug.
I can see two words.
Yeah. So basically, I started to look in the /docker directory. Lotta, if you can go to the code and go to Falco Docker. There you go. So it looks like we have a lot of Docker files in here, and some of which are, you know, coupled with the concept of an operating system. Some of which are coupled with a concept of their size, if they're slim, we have dev, we have stable. There's a lot going on here, and I think it just might make sense to look at the Docker images we're using, to look at our use cases, and to make sure that, you know, we're not only building, but also supporting whichever of these as a project we decide to build and support. So, I mean, it's good for today, but like, for instance, if you go into the stable directory, in there, open up that Docker file, look at line 1. Our stable Docker image comes from Debian unstable. And it just kind of seems like we should maybe go through and look at a lot of this. Another kind of, as I'm thinking out loud here, another thing here is if you go back to the issue tracker, I opened up another issue about operating system supported packages. So with the new Circle CI builds that we started doing, we generate Debian packages, we generate RPMs, we generate, I even think we can do tarballs just to get like the gzip of the binary information itself. But as we start to look at building and supporting different packages for different operating systems, that ultimately could simplify our Docker builds as well, right? So from Debian, all we really would need to do is an apt-get add repository, apt-get update, apt-get install Falco, and that's kind of done, right? And so I just think, you know, as we start to look at the build and release process, simplifying a lot of this and moving the bits of logic that belong at the operating system level into the operating system level packages is going to be a big win for ourselves in the rest of the project. And again, this goes back to making Falco easy to consume and driving adoption to the project.
Yeah,
So that was kind of my thoughts here. I don't know if that resonates with people or if anyone has any experience with, you know, maybe we do want the logic in the Docker file, or we do want the logic, you know, in the operating system packages, or thoughts or ideas, pros and cons to either approach.
Can I talk 5 seconds about 2 or 3 Docker files that we have to add more
Yeah,
context?
please.
Okay, can everyone hear me? Okay, great. So right now we have Circle CI, right? Circle CI is using, if I open it quick, it's using build Ubuntu Bionic and build CentOS 7. So build Ubuntu Bionic is basically just doing what Chris was saying. Just takes a Docker image, which is not in the form of a Docker file, but in the form of a Circle CI. It's the same thing. And just install some build packages, and then builds Falco and do the stuff. Build CentOS 7 is based on the Docker file builder, which is this one, which is very huge. Well, it's huge for me. And that has this dev2set7 GCC toolchain, which is compatible with, you know, older glibcs, basically. So the issue that we are having here is that we need to be compatible with, you know, we cannot like use GCC 9 to build Falco because it will not work on all the glibc. Let alone this stuff, we can, I mean, make this better. We can do that, but with other tricks, whatever. I'm just saying that we have these 2 things. That's why we are building the packages using this, because in the way it's done now, it will build Debian and RPM packages that will be compatible with most of the distribution that our users use. That's why that takes a lot of time. Also, after that, we have this local Docker file, which is not used anymore in the CI, which was used for integration testing and for local development by some developers years ago, probably, which contains, again, all tool chains like GCC 5, GCC 6, GCC 7. This was supposed to create kernel modules that were compatible with, kernel 2.6 and stuff. But it's not used anymore in the tests right now. And then, as Chris was saying, we have, this is another kind of Docker file, the stable one, where we just basically install the Falco package. And right now we are installing tool chains because we need to build the kernel module. And I disagree that this should be here, honestly. We should just install Falco and Falco runtime dependency, and the tool chains should be in a init container if we build it, or if we build that, piece of software that just builds for you in that place.
Maybe I remember wrong, but Laura, if you go into the kernel subdirectory.
Where?
Right there in Docker.
Yes.
There should be probloader. If I don't remember wrong, the scope was when Michael did this, if I remember, to use it as a init container for the other. but maybe I'm remembering.
Yes, but this is just loading the kernel module.
Yeah, not building.
No.
Yeah.
And I don't know if you were in the call before, we were talking about having a service where you pass the information of the module you want, like, what kernel flags, what kernel version, what Falco version, and it will build the module for you so that you can download it in 10 minutes.
Okay, so that service in paired with a Docker image like this that basically uses Falco CTL to download the probe would make it, right?
Yes, yes.
Okay, so I was saying correct. Okay.
Yeah, you were saying correct. I just wanted to understand if you were completely synced.
Thank you.
So in the name of figuring out how we want to support various Docker images moving forward, like I think we should keep, obviously it's not going to do us any good to just start randomly deleting things, especially if people are using it. And we've already put a lot of work into this. But I think it might make sense to start to look at a concept of like Falco 1.0 supported Docker images and starting to explore, what is the story behind the scope of each of these container images, right? Do we want to offer an image that will do the timeouts and waits and then tries to start Falco? Do we want to do init containers? I think, again, there's a lot of this that we kind of need to start thinking about and talking about. I don't think we're necessarily going to solve it on this call, but I think, as the project moves forward and as people want to get more and more involved, if anybody has questions or ideas about how we can start keeping these concerns separated while still giving operators everything they need to be effective, I think it's going to really be helpful for the project. Yeah, tell me.
I have thoughts about this. In fact, in an issue, I wrote that I would like to deprecate the Debian unstable images, namely the local and the dev1, for some reasons. First reason is that going towards that 1.tx line of Falco, we don't need anymore to do all this mess in Docker images, in my opinion, for the simple reason that the inputs that maybe will need to load kernel modules or use probes will be separated for the Falco core. So will not be any more responsibility of Falco to provide images that basically builds and then runs kernel modules. So we will not have any more the need of using all these tool chains. Furthermore, at the moment, we could start deprecating the dev and the local Docker images because we are not using them anymore in any place in the code. The local one was used with the Falco tester. Basically, the Falco tester was using the RPM.
We already told this, Leo.
Okay, sorry.
So here would be my suggestion. Now that we have resources from the CNCF to build and support artifacts, I think Docker images probably are clearly the first one that, it's going to be easy for us to tackle and that most people are going to use, low-hanging fruit. I think as we move over to the newer infrastructure, that's a good opportunity for us to choose very carefully which Docker images we want to start supporting. And we can maybe start to separate that out in the repository by keeping, the new infrastructure images separated from the legacy ones and making sure that, as we move Docker files from the legacy directory to the new infrastructure directory, we're also with that move symbolizing some sort of a support guarantee for the open source project that we have acknowledged that we're going to not only support this as it is today, but maintain it moving forward. And there's, as a security tool, we have a responsibility, if there are bugs, if there's vulnerabilities, if there's patches, there's a lot of this that we need to start kind of thinking about and at least documenting what our guarantees are here. Okay.
Okay, next. Bring the build release process completely in the open.
Yeah. Basically in that, yeah, thank you. If you open that ArchMD link, here there is the current release workflow. There's a part that's open. I mean, that's through GitHub. like creating, adding additions to changelog, editing the README, the Docker image, the Falco versions in the Docker images, the YAMLs in the examples on the integrations, the website, things like that, and creating a PR. Okay, and then there's a whole pipe of steps, which is in the Jenkins and the Sysdig Jenkins, which means that we should replicate those steps in the open some other way. For example, to summarize, we will need a bucket where to store probes, if we want to do that way, and another bucket where to store packages. We need that the ownership of the Falco Docker app account is in the open or not Sysdig owned, and this is to summarize the problems. And basically, the closed steps are simply Jenkins jobs that builds Falco packages, then builds probes and push to some S3 buckets.
Can we, I have just a quick question. Can we document either creating a new issue or just adding it to the HackMD and we can create an issue later, what tools we would need from the CNCF in order to have parity with the build as it is now? It sounds like all we really need is storage and Jenkins, right?
I don't think we...
I agree with you. We don't need...
Let me show you. Like when we released Falco 0.19.0, there was a situation we noticed, right? The Sysdig Jenkins was built in Falco again. Falco was already built by Circle CI for that branch, for that tag, and was just pushing the Debian and RPM packages, and then was pushing the Debian and RPM packages to S3, right? But it could have just been downloading these two files from Circle CI at this point and pushing them to S3. So that could be done with a Circle CI job,
yeah,
or with whatever. It's just copy to an S3. And on an infrastructure point of view, I mean, it could be S3, whatever. We just need a web server with a specific folder structure that should match the way that Debian and RPM expect packages to be. They can be an S3 or whatever we choose. So it doesn't need to be.
I have a question. So here you have RPM, Debian, and the tarball. If I had, let's just kind of thought experiment. If I had a brand new Ubuntu 18.04 computer, I could download that Debian package. Would that also set up a kernel module for me?
Yes, it will be.
Okay. So it seems like the service, hold on one second.
Sorry.
No, it's okay. It seems like the service we were talking about earlier probably would benefit from also managing these artifacts here as well. So it sounds like, you know, as we start to design downloading Falco probes and Falco BPF probes and Falco kernel modules, we probably also should just make the Falco package itself downloadable in the same way for the same benefits that we would have. I see Lotte shaking his head. In which case, all we would really need to do here is kind of like what you were saying, Lotte. It's just have some sort of automation in place that takes these, puts them in a well-known location that the new service could access, and then the service is just responsible for routing those requests and generating things as needed.
Like in stupid words.
You're muted.
Like if you're
muted.
Oh, sorry. It's because I wanted to use your microphone because you're on mute. Yeah, this is a problem. So in stupid terms, imagine if you had like a main Go with a router with, you know, / probes where you just do a get, where you ask for the probe to take that get. The probe is not there. It will test you, I will create the, like with some HTTP code, I don't remember which will be, like accepted, whatever. We said, and it will create it. And you can use the same router also to let you download the, like, it's an implementation detail. I just wanted to say this to understand better each other.
Okay, I have 2 more questions now because we all know the way my brain works and I have a million questions. Number 1, well, I guess the first one's a comment. I will add what you just said to the action item I signed for myself earlier about creating an issue and a proposal for this new service. But as you were talking, I also started to think about, as a security tool, how do we know, because you said HTTP, right? And that got me thinking, oh, should we encrypt this new service? And then I went a step further and said, what about authenticating that there's not a man-in-the-middle attack here? So do we want to build in some sort of ancillary tooling that does some sort of either GPG encryption or authenticating to make sure that when you actually curl and get a Falco package or a Falco kernel module or a Falco BPF probe, you in fact are getting what the community is supporting and not something else?
I think we should sign all the packages with GPG.
Okay.
And they should also sign the probes. I agree.
Okay, so I'll add.
So for the packages, is already built into the packages. While for the Falco probe, we should GPG check when we download it.
Okay.
And make that configurable because people might want to deploy that in their own infrastructures.
Okay, I'll document this and put together some user stories and some stories around the user experience here. And as soon as that's documented, I think, we kind of have everything we need to get started.
And then depending on how we want to publish those artifacts for RPM and dev packages to that service, we could make an authentication to let CircleCI authenticate there or something. Or we can tell that software to go take the packages from CircleCI so that we don't need anything. But it should be secure. I mean,
yeah,
as best as we can.
Absolutely.
Yeah,
And this also just drastically simplifies this entire process in general, which anytime we can free ourselves up from a support burden, I feel like that's really meaningful for an open source project.
What if we just create a proxy that simulates an RPM repository or a dev repository and then gets file from CircleCI artifacts API?
Mm-hmm.
We can't because those files disappear from after some days.
Oh, okay. So
I was thinking about the same, but we can't.
So we need like a job that pushes in the repository. Another
pull
job.
them because we don't need to.
No, I mean, Lore, in CircleCI, we can create another job that only runs, for example, on tags, on Git tags that pushes the packages.
Yeah, I know, but if we do that in the other software, we will need to have an authentication for CircleCI to authenticate because if not, everyone can push those to that.
We can use CircleCI.
We can instead go and pull from our software the URL from CircleCI because CircleCI is a very well-known API that probably has a Go package
client.
Or something.
Yeah.
A Go client that you can use to take the last artifact for the tag.
Okay.
In my opinion, should be easier, but we can discuss that.
Anyway, so we need repositories for the RPM and the service that you were talking about, right?
Mm-hmm.
Okay, I'm taking note.
Which is all the same service, but with different routes.
Okay, taking note.
Okay, we have 10 minutes left in the call. So is there anything else? We have some more items, and I have a feeling that this is going to be the first of many of these build release calls, at least for the next 1 to 3 months or so. Is there any other items folks wanted to focus on in the remaining 10 minutes, or should we just continue to go down the list here?
We are forgetting one thing in the release workflow. Sorry if I bother you with this, but we need Docker image at the moment. Lorenzo can confirm are built manually when we draft our release. We need to automate that with CMake, with CircleCI. I don't care, but we need to automate.
Yeah, I added a point on that. We should totally tell Circus CI to.
You buff mute.
Sorry. We should tell Circus CI to build and sorry, this was not this one. To build and push the Docker images, but only for maintainers and only for our branches, because we don't want to push on the Falco security org from malware or something. So if it's the main fork or is a maintainers fork or is a Circus CI can do that, or is a stable branch like dev or master, we should push the Docker images so that whenever we tag at the end of the build, the Docker image is already pushed. We don't need to.
Okay. Rajib has a good point in the chat, in my opinion.
Yeah, if you can use that feature of GitHub, recent feature, it would be very much useful. Yeah.
What feature is this?
The feature of go
it's a
Rajib.
GitHub, yeah, so it's a GitHub's package, so where we can push and pull the private Docker images. So let's say Falco has several Docker images. We can even push it to here as a GitHub Falco Security Falco as part of our Circle CI job. That's what I thought actually.
Yeah, this looks great.
Yeah, this solves the Docker Hub ownership, like.
Yeah.
Can we add a link to this to the doc, and I'll make sure to include this in the proposal that I'm working on.
Yeah, and if we want, we can just have the Docker Hub to be a replication of this, so that we don't have to deal with permissions on it.
It's very good.
Yeah, we use GitHub permission. This is perfect. Thanks, Rajib.
Sure.
Good job, Rajiv.
I hope these had apt and RPM packages.
Would have been rad. Perfect. Would have been perfect.
And also
That's
kernel
all.
module packages. Don't write any. Thanks, Rajib.
Sure.
Okay, I'm going to give us the last few minutes back if folks don't have anything else. It sounds like the main next step here is.
Oh, sorry. Can I just add a thing? Sorry.
Go for it.
Dev branch will become the master branch. I think it's a thing to decide that is on this team. We have the dev branch. We treat this as a master branch. The master branch is behind ages. We just have to make a decision and destroy the actual master branch and rename dev to master, in my opinion, before we start building any more infrastructure that uses the name dev branch in it.
Two thoughts here. First one, is there anything blocking us currently from doing this?
Nope.
Okay. So second one, can we do this? We've been talking about this for months. We just need to get this thing over with. Let's do it, but let's also make a copy of the master branch, master-backup or something, so that we at least preserve that history. And then let's force push dev to master and add a note to the dev branch README that it's deprecated. And over time we can make that deprecation more official, and then ultimately we can completely remove that branch after we're several versions into the master branch. This is something we have to do very, very slowly.
Yeah, it is exactly what me and Lorenzo told. In fact, in that issue 726, we proposed some months ago to do this. We just need them to probably GitHub automatically rebases PR against master. I don't know. We have to check, but it's something that we just need to do, and the plan is already there.
Okay. Is anybody?
If you all agree, we can proceed. This is my question.
So I think we can proceed, but I think there's two things we need to do. One, we just need to be very clear about what we're doing. If we could send an email off to the mailing list, and that way we can forward it off to our end users, particularly anybody at Sysdig and our other end users who are using Falco. They probably would want to hear about this. And if we send an email to the mailing list, that gives us something that we can just forward off and say, this is something we're planning on, thoughts, questions, concerns, comments. And then otherwise, yeah, I think it's just, we need somebody to kind of own this and just make sure it gets done.
I think we should announce and just give them some time to react and then do it.
Yeah, I agree. Any volunteers to send off an email to the mailing list?
I can send it.
Okay.
You loves that.
Yeah, I mean, this makes me not sleep.
Yes. Okay. Anything else? 2 minutes left.
There's another thing. Sorry.
Tell me, Leo.
I know. This is my call. I was waiting for this call since 6 months. Sorry. Me and Lorenzo asked to CNCF to put Falco in the cncf.ci website and service. They accepted. They gave us access to packet. We asked for 3 servers, if I don't remember it wrong. Then we also asked for creating the Falco configuration for this website. And someone from CNCF or from Vulk company started doing things about Falco. We should just get in touch with them, understand what are the next steps to have Falco listed there. Because basically, what I've understood is that CNCF CI is just basically a bunch of jobs on their GitLab CI that reads project CIs like Circle CI, Travis, statuses, and reports back to that website.
Okay.
So, yeah, this is what they created. We need to contact them, update maybe the version, and ask for the next step.
Yeah, we can also always just open up a PR. I think I am a member of this org, so I might even be able to merge it. But yeah.
We opened for updating the Circle CI, but we need, my problem is that I don't know what to do next to have Falco there on that website.
Okay. I see what you're saying.
Like to actually appear here.
You're muted.
Yeah, to appear here. I want Falco to appear here in incubating projects.
Okay. Let's again. I feel like the mailing list is the best place to start this. If we get the mailing list, I can start to bug people and ultimately use that email to send over to the CNCF service desk and get us what we need.
Okay, I see your point. Okay.
Mm-hmm.
Gotcha.
Leo, do you want to take that one as well?
Thank you, Chris.
Thank you, Leo. Okay, we are officially out of time. Well, hold on. Next week, same time, same place. Does this work for everyone?
Works for me.
Okay. And on that note, we'll see everybody next week. Thanks for joining.
Cool. Bye-bye. Thanks.
Ciao.
Thank you.
Bye. See ya.
Oh, wow. There was a lot of people on that call.
Yes. Do we open an issue before we forget?